Okay, and we're live for the final session of JNation 2021 online. So thank you so much for everyone that's been keeping with us for the full day, or even if you just joined now, it's also fine. We are quite tired, but I mean, one person that actually raised my spirit is actually Jonathan here, a good friend from the Barcelona jug. Hey, Jonathan, how's it going?
Yeah, fine, fine. I'm a bit tired too, but not in the same amount of, about you. But yeah, happy to be here.
Wonderful. We're really happy to have you here as well. So if you have any questions for Jonathan, please let me know on our Slack, on our YouTube chat, and I'll be happy to relay them back to Jonathan. And I know that Jonathan has a lot of ground to cover, so I'm just going to hand it over to him. He's actually going to present a very cool topic. It's one of my favorite technologies is test containers. So I'm really glad I'm going to hear a little bit more about it. So Jonathan, the stage is yours. Feel free to go.
Okay, okay, thank you. Um, uh, as you say, yes, I hope to pronounce it correctly. Obrigado. To be here and share my little knowledge with this JNation amazing attendance. Um, well, now I'm going to show you my experience working with test containers as a result of having this need of testing our whole application. And after searching and testing different things, test containers was the answer. So let's see how we can test as if we were in production with test containers. Let's rock. So table of contents. Well, first I will introduce myself for you to know who is talking to you. Then I will share which is the project that we were trying to test and the complexity of the project. After that, I will share which is, well, all the presentation should cover the why and the what. I mean, technical stuff is not the goal, is the result. So which was the, let's say, business problem or technical problem that we were wanting to solve, and what was the result is going to come later. Then I will, well, introduce a bit of what is test containers, as that was well, the technology chosen at that moment. And after that, well, we will see how we were using test containers in our project with the same architecture that I was presenting on the step 2. And after that, I also want to share my latest experiences with test containers. Um, let's say that the last year I've been working mainly with Quarkus, and I've created 2 different applications. And one of them has been using very intensively test containers. So I will show you how you can use test containers with Quarkus. It's a very easy and it's very useful. Finally, I will share some references for you, well, to know more about test containers, or well, the links to the GitHub projects where you can just check the code. So who am I? Well, I'm Java champion. I'm also co-leader at the Barcelona Java user group. I'm co-founder of JVC and Conf, a conference that we host every year in Barcelona. Now the next edition is going to be hosted virtually the next 23rd of July. And I'm also working as a software engineer at Red Hat in the application modernization and migration team, but that's only up to 1st of August that I will be joining the Keycloak team. Here on the left, you have my Twitter handle, my email, my blog, where you will find my posts, and also my GitHub account, where you will find the code for this presentation and others. And also, well, my work at Red Hat is there. And finally, that's my face. So that's I'm the guy that it is being used like canvas for I don't know, Miro or any other abstract painting. So let's see which is the project that we wanted to go a step further in terms of testing. Well, our project was called Xavier in English, Xavier in Catalan. You can call it as you want. In Spanish, it would be called Javier. So, well, you can call it as you wish. That application was a camel integration application that was in the middle of several layers and several other applications, and was like taking information coming from the user and then sending it to other applications and collecting the results, and in the end having, let's say, the sum of those results and put it in the database. So the flow was a user calls our application with a REST API, uploads a file. Our application sends this file to another service. It's a Red Hat application. It's also stored in GitHub. This application will do several things with this file, several validations, and then it will put this file in an S3 bucket. Okay. Also, it will send a Kafka message saying, okay, a new file has come to the system and it's valid. This message will be consumed by several applications, and one of them is our application. So let's say that we have the validation system delegated to an external application. Well, our application receives that message saying, okay, that file has been validated. Then it will call, or it will retrieve the file from an S3 bucket. It will process this file. It will break this file into smaller chunks, and it will store those chunks into the database. After that, it will store also this file into another S3 bucket and send these chunks to a key server, an external system that has several rules to do some calculations about this file. And then it will take this information and it will store it in the database. Also, we need to take into account that everything is controlled by a role-based access control application using Postgres, a Keycloak one. Well, in this case, it was Red Hat SSO, but well, it's the same. So now you have the idea of the whole system. So obviously, we can have unit tests. We have them. You can have integration tests. But if you don't go one step further, you don't have the confidence that everything is working until you deploy it in production. Or you have a pre-prod system where you deploy everything and then you upload the new version and expect nobody is touching the system, and you run the tests, everything is fine. Other times it's not fine just because someone changed anything, or because your tests are not idempotent. So every time that you do your tests, you're leaving something behind. So probably what you need is something that you can create everything, test your application, do like the happy path or even performance paths, and check that everything works fine. So now we want to see what do we want to test with this application? Well, mostly I have already told you, but in this case, specific points that we want to cover in our tests. Well, we want to cover client network connections. What I mean is we are using Camel in order to connect to different endpoints. And we want to be sure that nothing has come into the Camel routes in order of wrong params, I don't know, typos, or any other thing that in an integration test could be not affecting the connection because you are introducing a param that is not affecting really the endpoint. But in a production system, you will be affecting because you can mess with the index for the Kafka broker, or you can mess with the, I don't know, the user used for the S3 connection, or even with the PostgreSQL. If you are not connecting to a PostgreSQL and doing the test, you could be doing, I don't know, wrong query. So this is the first step that we want to test. Another one is testing external services version. So I want to be sure that, as if it is said that in production, these are the versions that are going to be running. So PostgreSQL 9.6 and Kia 7.3. It's not that if I test with a let's say not ephemeral system where I put my database 9.6, but in 2 weeks we decide that we are going to use a feature that it's introduced in PostgreSQL 10. What happens? Either we update the not ephemeral test environment, or we don't implement that feature just to stick with PostgreSQL 9.6. So what we want is that we can be fast testing even the versions of the layers that our application is depending on. As I said a bit before, we also want to check the timeouts, params on the clients and listeners connecting to external layers are going fine. And also, there's there are two processes that are running in background. So there's this inside ingress service, and there's this Kia service. Those are running in background and doing some things. But I want to test my application with the real code of those two layers to see that the timeout that I'm applying to my connection in Camel to those external layers is not too big or too low, or those systems are sending a wrong response because, I don't know, anything can happen that I have configured wrongly the Kia server and it's returning something wrong. So we want to also test our application among the background async processes. And also the last one is that we want to test that our service is running correctly, considering a specific configuration on the external layer. So yes, this Kia server is going to run correctly, considering the configuration that it is specified for the production environment. So I want to check that everything works fine. Nothing is going to be broken in the future because of something in the configuration. But the most important point about all of this is that we want to test this, but not using a human and not using a complex system that has to be executed, triggered by a human, for instance. What I want is to have this for every pull request that anybody in the team creates for this project. This is going to take a while to do all those tests, as you can imagine. But to be honest, I don't care. In my team, we don't submit 20 pull requests per day to the same project. So as we don't do that, we can just submit a pull request. In this case, Travis CI will execute the pipeline, will boot up all the infrastructure with all the layers, with the configuration, with everything, and will run several tests: a happy path, a performance test, and a corner case test. This is exactly what we test here. As you can see here, well, we have in our CI, in our pull request, it says, well, this Travis CI pull request check has passed, so that's fine, we can merge it. And in the right, we have the screen from the Travis CI. So it took 47 minutes, so it takes a while, especially because we are creating all the elements for the infrastructure. And also, in this case, our tests are covering 2 super big files. So we are testing the happy path, and we are also testing wrong files, where we know exactly which are the issues included in those files. And also we are testing with big files to test the performance. You would say, what's the point of testing performance in a CI environment? And you're right. So the point here was that considering the resources that we have in Travis, the performance test needs to finish correctly in a certain amount of time. I know in production that time is not relevant, because in production is going to be far less than the time that it's taking in CI, hopefully. But in this case, we are running, as we are doing several things in parallel, uploading different files, we are testing that the super big file is not affecting others, because we have a thread pool where of 5, I think. So we are uploading several files, 6 files, checking that the first 5 are not affecting each other, but the 6th file is really put on hold until the smallest from the first bunch is finished. So we are checking several things, but every time, and with the real layers. So after checking several things, that could be Travis CI, start a container, install and do all the bash commands to install everything, to put the configuration files, we decided that probably that involves too much. So a nice thing was to consider everything as a container. But the most important thing is that those containers need to be connected somehow with our unit tests. So, well, JUnit tests. And this is where Testcontainers came to the rescue. And I have to say that after trying Testcontainers, I'm in love with it, and I totally encourage you to use it instead of using mocks and fakes. This is totally an amazing technology. So let's see, what is this thing called Testcontainers? Well, basically it's a Java library that is supporting the JUnit lifecycle, and it's providing lightweight way to use Docker, containers. In this case, Docker containers. We can use several Docker containers that are coming out of the box with Testcontainers, or we can create our own. So we will see in a minute. So basically, it's that your app is having a JUnit test that will have a Testcontainer module that will use Docker for Java, and in the end, it will have a Docker container. So basically, that's it. It comes with different and several flavors. We are using the Java version. This is the last one, but it comes in Python, Node.js, Go, JavaScript, .NET, Scala, and Rust. So you can have several different languages or flavors of test containers for your language. So what are those out-of-the-box modules? Well, test containers come with different, let's say, pre-configured, pre-optimized containers or modules in this case. So it has 18 DB modules. So, well, most of the databases are already present as a module for test containers. And an out-of-the-box module means you simply instantiate it, and it provides 2-3 different properties that you can configure. And it is abstracting you from really a Docker image file or any other particular infrastructure that you need to use to create this container. Also, it has, well, in this case, 12 tools that you can use. We are using local stack, and we will see in a minute, and Kafka, but you can have, well, several that you can use. It's very convenient and very easy to use these out-of-the-box modules. So the task that you can do with containers, with test containers, are, well, first you define which is the container that you are going to use. There are several ways of doing it, but basically, out-of-the-box module, a Docker image file, sorry, a Docker image or a Docker file. After that, you will start these containers. You can do it manually, and you can do it, let's say, automatically with a JUnit for rule. And in manual, you can run it in sequence, or you can run it in parallel, specifying dependency between the containers. Obviously, you need also to get the log for each container. Logs are like, I don't know, umbrellas. So unless it is really raining, you are not going to use it, but it's better to carry one. So in this case, logging, well, you will be interested to know what happened when something was wrong, and to see the logs for the different containers. After that, you have everything created, but then you need to connect your application to those containers, because your application needs to connect to the database or to Kafka. So you need to obtain the IP and the port for each container. And there are several things to consider here. In order to avoid port clashing between containers, so we can start 2 different PostgreSQL, and although the internal port is 5432, if we start 2 containers with that port, it's gonna clash. So to avoid that, test containers is always starting the containers using random ports. So for each container, each time you need to get and query which is the port. And also you can even create shared networks where those containers are going to be able to connect to between them using the name that you provide as an alias for that, let's say, private network. And finally, in the end, you need to finish those containers, or manually or automatically, we will see. So let's see the usage of those test containers in our project. So as you can see here, we are using almost everything real, except for one thing that, well, you will agree with me that it makes totally sense. So in this case, what we are not using as the real layer, but we are using something that it is, let's say, compatible with that layer, is Amazon. So as we don't want our tests to be coupled to a particular instance in Amazon that can fail, that the certificates can, I don't know, expire, that you don't have a connection at that moment, or even that you need to have that instance running all the time. So you have to pay for it. So in order to isolate our test, what we are going to do is use a substitute for Amazon. In this case, Minio for the S3 buckets, and also local stack that provides exactly the same. So this is the idea, to have everything real except those two modules that we are going to use something very similar but not exactly the same. So at the moment, to define a container in our code. So for an out-of-the-box module, it's very easy. As you can see here, we go to our unit test, and we simply instantiate, in this case, PostgreSQL container. This is a container class for the out-of-the-box modules that provide test containers. And in this case, we say, I want a PostgreSQL container with this database name, with this user, and this password. That's it. This will imply that test containers starts a container, and in this case, a particular version, unless I specified which version I want for the database. So it's totally abstracted from me, which is the real steps to get this PostgreSQL container. For those services that we have the Docker file, and we are going to create the image on the fly. So in this case, we are going to create a generic container, and we say, okay, create this generic container, but using this Docker file, and with these exposed ports in this private network, and with this log consumer, and with this prefix for the log consumer. We will see this in a moment. What test containers will do is, okay, it will take that Docker file, and it will do a build and run the container. And we do that with the Ingress service. That in our test, we download the archive from GitHub, and we create the image on the fly for our test. And the last option to define a test container is using the image from the Docker Hub. In this case, we are saying, okay, you create a container using Minio image from Docker Hub with these commands and these properties, and in this case, with these environment variables. So considering this is the real picture of our system. So we are going to use generic containers with the Docker Hub image for Minio, and for Kie, that's it. Then for Ingress and for the RBAC application, we are going to use a Docker file. And then for Kafka, local stack, and PostgreSQL, we are going to use the out-of-the-box module. Okay. So regarding starting the containers, well, it's very obvious. So we use the instance created, and we call start. This is the manual version. Or we do manual, but in parallel. So in this case, as you can see, we are doing startables deep start, and we are specifying a list of different containers. And then we say, okay, join, so it will start. But on the definition of each container, we have specified on which other container my, in this case, create buckets depends on. So test containers will not start create buckets until Minio container is ready. We will talk about readiness in a moment. And that's another way that it is doing it automatically using rules, and then Testcontainers will align the test lifecycle with the container lifecycle and will start and stop it for you. Regarding the logging, well, it's in this case, for each container, we specify which is the log consumer. We instantiate a new SLF4J log consumer, and we add a prefix. This prefix helps to split the information in the whole log that we will have in the output. As you can see here in the screen, we have several logs with AWS log or key log. Those are the prefixes that I've added here in the logging. And that's why you will have, well, the information, you will know from which container it is coming from. And connecting to a container, well, once you can connect containers to other containers using the name, as you can see here with this private network, and specifying the alias for the network. So in this case, it is using the same network as the ingress. So the ingress network that will be used by the ingress service also. And in this case, it's using the network alias Minio. So any other container in that same private network can connect to this Minio container using the name Minio without knowing the IP. So that's the way to connect between containers. But in order to your test to connect to those containers, as I said at the beginning, you need to get the IP address and the port. So in this case, for the Kafka one, well, we are getting the information from the Bootstrap servers, and we will take the information for our application to connect to Kafka. For PostgreSQL, well, with the PostgreSQL container instance, we get the first map port and the container IP address. And those properties are going to be put into these properties we will see now in a minute in order for your test to be able to connect to those containers. As I said a moment ago, there's this concept of dependency between containers and this readiness concept. So usually a container is ready if it is running. That's it. But you can specify the wait strategy. So a container will be ready when, in this case, waiting for a log message appear in the log, or waiting for an HTTP call returns a status code, or even for the health check function. So those are the three ways that our container can say, I'm ready because of this condition. If not, it's simply, if it is running, it is ready. Our application was a Spring Boot application. And obviously, we have all the properties configured in our properties file. So we need something to tell the context, the new properties, in order to be able to connect to the dynamic and ephemeral containers. For doing that, we were using a context configuration annotation, where you can specify a Spring Boot initializer. And this application context initializer, what it does is simply, well, add to the context these properties. And we are going to do this after all the containers that were running as static instances are already available. So doing this, we will run all the containers, and after that, this class will get all the information from the different containers instances. And then the test will even not know that it is connecting to the containers on the test containers. And finally, to finish the containers, it's, well, It's easy. Just simply call stop manually. Or as I said before, using the rule for JUnit 4, then they will be finalized by themselves. So this was mainly the presentation for the test containers with our application. But I wanted also to share with you the usage of test containers with Quarkus in my latest project that I also think it's very interesting, or at least it is for me. So with test containers, with Quarkus, everything is easier. And this is also true for test containers. Quarkus provides something called Quarkus Test Resource, and it also provides some out-of-the-box classes like H2 or others, but you can create your own. And basically, a test resource is a class with 3 different methods that are going to be aligned with the life cycle of the test. So in order to have PostgreSQL database in our test using Quarkus, simply specifying Quarkus test resource annotation and then PostgreSQL database test resource. And we are specifying a list of init args, so arguments that I'm going to pass to the test container. The same in this case with keycloak. So we are booting a keycloak instance, even specifying the realm JSON, and that's it. For our test, everything will be the same, and it will be connecting to that database. And this is the class that it is defining the PostgreSQL database test resource for Quarkus to use test containers. What it's doing, it's for the init method, it is defining the container. So it is using the properties that I passed with the init args. It is starting and it is returning a property with the value that we get from the PostgreSQL container. And this property is the one that it is used in our tests that is specified in the properties file. So this will override the property in that file. And in the end, it's PostgreSQL container close, and this will be called when our test finishes. That's it. So that's been all for the presentation. And now I want to share with you some references that you can use to go further in this topic. The Test Containers website and the Twitter account. Also, if you want to know more about the Docker for Java that it is used for in test containers, you can use the GitHub project, Docker Java. Also here you have the repository used in the presentation for the test containers project with the 8 layers that I showed you in the beginning. This is the project. And the repository for the application that it is using Quarkus with test containers, where here you have the two repositories, and you would see that the code that it is very, very easy and very, very convenient. And that's been all. This has been all my presentation. I hope you enjoy it. If you have any doubt or I can help you using test containers, or I can share my little experience, please contact me at my Twitter handle, my email, or check my repositories in GitHub, or even my articles in my blog post. That's it. Thank you very much.
Hey, Jonathan. Yeah, man, great presentation. Thank you so much for bringing this to the JNation this year. Yeah, so actually, I don't think we have any QA for you, but we do have an interesting comment. saying that, yeah, the world needs a test compose functionality, which is quite funny. But other than that, I think we don't have anything else. We have a couple of smiles, so people I think enjoy the talk. So yes, so thank you so much for joining us today.